Today we're starting Chapter 9, which is trig functions. This chapter is the first of 6 trig-related chapters. So we're on page 1 of our Chapter 9 notes packet, and our first section is trigonometry of the right triangle. You see this acronym SOHCAHTOA. SOHCAHTOA stands for S is for sine, O is for opposite, H is for hypotenuse, C is for cosine, A is adjacent, H hypotenuse, T tangent, O opposite, and A adjacent again. So there are actually 6 trig functions. You might be familiar with the 3, sine, cosine, and tangent, but there's also reciprocal functions of each. Let's recall our right triangle. Opposite the right angle, that's our hypotenuse. I'm just going to abbreviate HYP for hypotenuse. And if we have an angle theta, usually the Greek letter theta is used to represent an angle measure. If we have angle theta up here, in relation to angle theta, the side opposite it would be this side here. I'll just abbreviate OPP for opposite. And the leg that is adjacent to it, next to it, would be this side. So when we talk about opposite and adjacent, and it's all in relation to the angle that we're working with. And the angle we work with is always the acute angle, one of the 2 acute angles of a right triangle. And remember, the hypotenuse is always opposite the right angle. Okay. So sine, our first trig function, sine, which is abbreviated SIN, sine is equal to opposite over hypotenuse. So if we were asked for the sine of angle theta here, we would go to the length of the side opposite and then the hypotenuse. So it's the ratio of the side opposite and the hypotenuse of our right triangle. Cosecant, which is abbreviated CSC, cosecant, right, again, so cosecant is abbreviated CSC, and cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So it's ratio of the length of the hypotenuse of the right triangle over the side opposite our angle. So cosecant also, again, let me just write, it's the reciprocal of sine. So cosecant can also be expressed as 1 over sine. Next, cosine. Cosine, which is abbreviated COS. Cosine is equal to the ratio of the length of the leg adjacent to the angle over the hypotenuse. So cosine is adjacent over hypotenuse. Secant, abbreviated SEC, secant is equivalent to the reciprocal of cosine. So it would be hypotenuse over adjacent. Or again, can be written as 1 over cosine. Now, how do you keep track of the 2? Secant, how do I remember that it's the reciprocal of cosine? If I take secant, the abbreviation SEC, and look at it backwards, CES, well, that's almost COS for cosine. So I remember that secant is the reciprocal of cosine by looking at secant backwards. How do I remember that cosecant, which is abbreviated CSC, is equivalent to the reciprocal of sine? Well, if I look at CSC, S in the middle here, there's just one S for sine. That's my trick. Next, we have tangent. Tangent, which is abbreviated TAN. Tangent is equivalent to the length of the side opposite your angle theta over the length of the side adjacent. So tangent is opposite over adjacent. And again, I'm just abbreviating. Cotangent, which is abbreviated COT, is the reciprocal of tangent. So it would be adjacent over opposite. Or again, it can be expressed as 1 over tangent, the reciprocal of tangent. Now what we want to do is in the next 3 problems is given a triangle, the angle theta, and the lengths of some of the sides, we want to evaluate the 6 trig functions for the given angle. So if we look at our first one here, number 1, we have side lengths or legs. Remember, the 2 sides that make up your right angle are referred to as legs. We have side lengths of 6 and 8. All right. We can always use Pythagorean theorem to find the hypotenuse. So let's do that first. A squared plus b squared equals c squared. 6 squared plus 8 squared. That's 36 plus 64 is 100. And the square root of 100 is 10. So the length of our hypotenuse is 10. All right, so now we know all 3 side lengths of our right triangle. Now, in relation to theta, all right, I'm going to mark the side opposite it. So the side length of 8 is opposite, and the side or leg adjacent is the 6. And of course, the 10 was the hypotenuse. So sine theta is opposite over hypotenuse. O over h. The length of the side opposite is 8. The hypotenuse is 10, so 8/10. We can reduce that if we want to 4/5. Cosecant, which is the reciprocal of sine, hypotenuse over opposite, 10/8, or 5/4. Cosine, cosine remembers adjacent over hypotenuse. Adjacent is the 6 over hypotenuse 10. Don't have much room here, so I'm not going to reduce each ratio. Secant would simply be the reciprocal of cosine, so it is hypotenuse over adjacent. Do I have to write this? No. I could just write the reciprocal of 6/10, 10/6, all right? But this is new to you, so it would probably be good practice to write hypotenuse over adjacent. Tangent is opposite over adjacent. Opposite is 8, adjacent is 6, so 8/6. And cotangent is reciprocal, adjacent over opposite, 6/8. And we're going to do the same for numbers 2 and 3. All right, number 2, we have the legs are 5 and 10. So we use Pythagorean theorem to find the hypotenuse. 25 plus 100 is 125. So c equals the square root of 125. Or if I simplify this, 5 square root of 5. So this is our hypotenuse, 5 square root of 5. Label hypotenuse. In relation to angle theta, 10 is opposite. The side length of 10 is opposite, and the leg of length 5 is adjacent. Again, it's always in relation to the angle you're working with. So the sine of theta we want opposite over hypotenuse. Opposite over hypotenuse, 10 over 5 square root of 5. And if we were to rationalize that denominator, we'd have to multiply by square root of 5 over square root of 5. Yeah, I'm limited to the room here, so I'm going to end up with 10 square root of 5 all over 5 times 5, which is 25. And that's going to reduce to 2 square root of 5 over 5. Cosecant is hypotenuse over opposite, the reciprocal of sine. So that'll be 5 square root of 5 over 10, which we can simplify to square root of 5 over 2. Cosine, adjacent over hypotenuse, 5 over 5 square root of 5. These are going to reduce. I know I'm going to have to rationalize the denominator by multiplying by 1 in the form of square root of 5 over square root of 5. So I'll end up with square root of 5 over 5 as a final answer. Secant is the reciprocal, so that is hypotenuse over adjacent, which would be 5 square root of 5 over 5, which simplifies to square root of 5. Tangent of theta, tangent TOA, opposite over adjacent. Opposite is 10, adjacent 5, which reduces to 2. And cotangent is reciprocal, adjacent over opposite, 5 over 10, which reduces to 1/2. Our third one, here's our angle theta. 3 is opposite it. 7, let's put the right angle in here. 7 is the hypotenuse, and we need to find the length of the side adjacent. All right, so using Pythagorean theorem, a squared plus b squared equals c squared. 3 squared plus b squared equals 7 squared. That's 9, and 7 squared is 49. So if I subtract 9 from 49, I end up with 40. So b squared equals 40. b equals the square root of 40. Square root of 40, if we're thinking of simplifying, 4 times 10, square root of 4 is 2. So 2 square root of 10 is our value for our adjacent side. Sine of theta, sine, opposite over hypotenuse. Opposite is 3, hypotenuse 7, 3/7. Cosecant is reciprocal of sine, so it's hypotenuse over opposite, 7 over 3. Cosine of theta, adjacent over hypotenuse. Adjacent to theta was the 2 square root of 10, hypotenuse 7. So 2 square root is 10 over 7. Secant would be the reciprocal, 7 over 2 square root of 10. And if I rationalize the denominator, multiplying by square root of 10 over square root of 10, I get 7 square root of 10 over 20. And tangent theta. Tangent, TOA, opposite over adjacent. Opposite is 3, adjacent 2 square root of 10. Again, rationalizing the denominator, going to multiply by square root of 10 over square root of 10 would result in 3 square root of 10 over 20. And cotangent is the reciprocal, adjacent over hypotenuse, adjacent over opposite. Adjacent is 2 square root of 10, opposite is 3. Okay, so SOHCAHTOA, right? Have to remember that. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And then they're reciprocals. Cosecant is a reciprocal of sine. secant, the reciprocal of cosine, and cotangent, the reciprocal of tangent. Okay, and the last thing we're going to do is we're going to use our calculator to evaluate the trig function. It says to round the result to 4 decimal places. So with the calculator, one thing with the TI-84 calculators, the default mode for the calculator is radians, right? So if we're evaluating the trig function of an angle that is in degrees, we need to place our calculator in degree mode, right? Whatever's darkened here, that's the mode that we're in. So you see the third one down says radians. We want to arrow down and over until we're on degrees, press enter. Now the degree is darkened. So now we're in degree mode. So number 7, we want the tangent of 10 degrees. So on the calculator, we do have sine, cosine, and tangent, right? Sine, cosine, and tangent. So we just press tangent and then 10. And we're rounding to 4 decimal places, so this would be 0.1763. Next, I'm going to do number 11. Number 11 says secant of 29 degrees, secant of 29. Well, secant, we don't have that key on the calculator, but secant is equivalent to the reciprocal of cosine, right? Look at this backwards. It's equivalent to the reciprocal of cosine. So we can write this as 1 over cosine of 29 degrees. And now on the calculator, we can key in 1 divided by cosine 29. 1.1434. Next, number 8, cosecant of 40 degrees. Well, cosecant, the S right there in the middle. Reminder, that's for a reciprocal of sine. That's my trick. So we can write this as 1 over sine of 40 degrees. So we go to the calculator, and 1 divided by sine 40, 1.5557. Cosine of 3, just key in cosine 3 degrees, 1.9986. You can try the other 4. Next, sine of 51, 0.771. Cotangent of 38 degrees. That's the reciprocal of tangent, so this would be equivalent to 1 over tangent 38. So 1 divided by tan 38, 1.2799. Number 10, cosine of 89, 0.0175. And the last one, number 14, secant of 67. Again, look at this backwards. Almost looks like cosine backwards. So this is the reciprocal. It's equivalent to the reciprocal of cosine 67. 1 divided by cosine 67 on the calculator yields 2.5593. And this concludes our video for today. Thank you.